Alright, so we got exponents and order of operations stuff. Exponents are kind of like how we went from addition to multiplication. So what happened is, after they created multiplication, they found that they may multiply a number many times over by itself, like this, okay? So what that means is, well, it's kind of a pain. So they've made a shortcut for repeated multiplication like this. So what we have here is 4 being multiplied by itself. And in this case, we got 1, 2, 3, 4, 5, 6, 7 of them. So they made these exponents, okay? So this is called the exponent. The 7 is the exponent. Some people also call it a power. And then the 4 here, this is called the base. So we have a base value. That's the value that's being multiplied by itself over and over and over. And the exponent or power tells us how many times it's being multiplied by itself, okay? So that's what exponents mean. We need to be able to do this backwards, though, specifically for this exercise. So, for example, if you had 3 to the power of 5, it would be like taking 3 times 3 times 3 times 3 times 3. All right? Now, next up, we have order of operations. So the order of operations, some people like to memorize it by I think they call it an acronym, I forget. But it would be PEMDAS. PEM, that should be capital B, AS. Like this. All right, now each of these stands for something. Now the M and the D and the A and the S are together because we have to remember that these will happen from left to right, okay? So P is for, let me spell this wrong, parentheses, maybe. E is for exponents. MD, this one, would be either multiplication or division, specifically from left to right. So what that means is if we find division first in this, going from left to right, then we would do the division first. And same with the A and the S, that's addition and subtraction. But again, if the subtraction first comes first from left to right, then we would do that first. So add or subtract from left to right. It's important that we keep these in order because if we mix these up, then it's kind of like making our own rules for this, okay? So these exist for a very specific purpose so that we can all kind of look at things the same way and get the same answer every time. It's kind of like, I guess this is a good room for it because we're in the mortuary room. Did anyone notice that on the way in?
Yeah.
It's kind of creepy, right?
Just saying this class is going to be the death of us.
Yeah, I like that. That's really good. Well, as it turns out, not that we would be operating on dead bodies, but if a surgeon was operating on a healthy person, or I guess someone that needs some fixing, right? But if a surgeon does stuff out of order, then things get jacked up, right? Infections, or maybe they forget to take stuff out. All of that stuff is bad. Well, it's the same thing with math. When we operate on math problems, is that too cliche? When we operate on math problems, if we operate on it incorrectly, then we get the wrong answer. Does that make sense? Of course, the answers can't sue us, but. So let's start with these exponent stuff. Evaluate this means it wants us to find the actual value of this. So if we expanded this out, we'd have 4 times 4 times 4. 4 multiplied by itself 3 times. So if we do these first 4s, 4 times 4 is 16. But then we got this other 4 as well. So when we multiply that, 16 times 4. 6 times 4 is 24. Carry the 2. 4 times 1 is 4. Plus the 2 is 6. So this one is 64. Would it be great to type that into a calculator? Yes, it would. Unfortunately, we can't. So this one, 7 squared would be 7, but multiplied by itself. So now that we got 2 7s, okay? So 7 times 7 is 49. All right, now we're in the order of operations. Now remember, it's parentheses. There are none here. Exponents, there are none. Then we have either multiplication or division from left to right. Well, we do have division on this one. 12 and 3, right? So 12 divided by 3 would be 4. Yeah. So that gives us 18, and we still got the minus there. So now I've got no more multiplication or division. So I'm going to move on to subtraction, or, sorry, should be addition or subtraction, either way. There is no addition, so we'll do the subtraction. 18 minus 4. If it helps, do it like this, right? 18 minus 4, 14. All right, number 4. So there are no parentheses, no exponents, no multiplication or division, but there is addition and subtraction. Specifically from left to right, we'll have to do the subtraction first. So 10 minus 3 would be the 7, and then we still have that plus 5. So again, still just moving to the left, 7 plus 5, 12. All right, so again, no parentheses, no exponents. We have multiplication from left to right though. So 2 times 3 is 6. Then we got the multiplied by 5. 6 times 5 is 30. There we go. Once again, these ones are set up because some people do PEMDAS literally, meaning they would do the multiplication here first. But on this specific problem, we do need to do the division first because it's multiplication or division from left to right. Okay. So on this one, we got 10 divided by 2, which is 5. And then we'll multiply this other 5, which is 25. See, the problem with, if we did this out of order, is if you did 2 times 5, then you would end up with 10 divided by 10, which is 1. But we can see that's way off, right? And again, that's because the operation was done out of order. So the actual answer is the 25. 7, we've got the multiplication, but, and this is the thing that we want to do, right? We want to just do 2 times 3 first. But, and that happens because it's from left to right. But the problem is that's not how it works for these math problems. We got to look for parentheses. There are none. So we move on to exponents, which there is. Okay. So this is really 3 squared. So 3 times 3, which is 9. See, now we can bring down the 2, which is multiplied by the 9. We're done with the exponents. So multiplication or division. There's no division. There's just multiplication. 2 times 9 is 18. Now, it's important to remember on a fraction like this that the fraction like this is, the fraction line, is division, okay? So what we got to do is, well, actually, if it's a fraction, it doesn't necessarily make a difference that that's division yet. We'd have to simplify the numerator and denominator first, so the top and the bottom. Now, the bottom on this one is already 2, but the top is a 10 squared, which is 10 times 10, which is 100. See, now we can put this over 2, or divide it by 2. Okay, so I've got 100 divided by 2, which we can use long division for. 2 doesn't go into 1, but it goes into 10 5 times. 5 times 2 is 10. Subtracting, we got these zeros. 2 goes into 0 0 times. And we can see the answer is 50. All right, this one's good. We don't see any exponents, but we do have the parentheses on this, okay? So what this means is that we really get to separate this into completely different problem. So what that means is I've got this 8 minus 2 times 3. And I'm just going to focus on it. Don't worry about that 6 or the 2 or the minus. If we focus on this, we got the parentheses, but inside the parentheses, the order of operations start over. So in this parentheses in red, are there any other parentheses? No. Are there any exponents? No. Are there multiplication or division? Yes. I've got the 2 times 3, which is 6. So I've got the rest of this, which is 8 minus 6. So I don't have any multiplication or division anymore. So I can move on to addition and subtraction, specifically subtraction. 8 minus 6 is 2. See, now that I've solved that, I can look back at what I had left and put it back into the problem. So we had a 2 out in front of that parentheses, and then it was 6 minus that 2.
Thank you. So it'd be 4.
Yeah.
No, 4 times 2, which is...
So the next part, yeah, would be multiplication. Because now in this problem that we have, because we've evaluated that parentheses, there's no more other parentheses, no exponents, but there is that multiplication right here, right, between the 2 and the parentheses. 2 times 2 is 4. So now I got 6 minus 4, which would be 2.
So I'm doing it wrong then.
Yeah, I'm glad you brought that up, because that is what we probably would want to do if we just looked at it correctly, right? Is 6 minus 2 is 4, and then we would multiply that by whatever the parentheses is. But minus or subtraction comes at the very end, right? Like we did right there. Then we had to multiply the 2 by that parentheses, figure out what that is, and then we can do the subtraction. This one's great because we have lots of operations. Particularly, once again, I'm going to start with this set of parentheses. So I've got 1 plus 3, which would be 4, and I've evaluated that parentheses. That's all I need to do for that. So I still got the 3, the squared, and the plus 4. But then I'm going to look at 4 squared, which is really 4 times 4, which should give me 16. So I've got the 3 times the 16 plus 4. So I've taken care of parentheses, I've taken care of exponents. Now I look for multiplication or division from left to right. 3 times 16, this one a little bit different. 3 times 6 is 18. Carry the 1, 48. And then I've got this plus 4. So when I combine these, I should get 52. All right, number 11. Again, we have multiple operations actually inside the parentheses right here. So we just need to focus on this 25 minus 4 squared. So in the parentheses, we've got no other parentheses, but we do have this exponent. 4 to the power of 2, 4 times 4, 16. And then we've got the subtraction, because there's no multiplication or division, or addition. So we'll subtract these two, 25 minus 16. Need to carry the 1 there, so we get 9. But I've still got that 4 out in front. So 4 times 9, 36. Take a moment and try 12.
So do those.
Well, he's on the first day, right?
Yeah.
So on this one, especially with these different types of parentheses, we got to keep track of the different type of parentheses. So they got the square brackets, and see how we got the other square bracket between the 4 and the 3. That means everything inside it starts a new set of order of operations.
So you just gotta
So we
add
do
that.
So hopefully we see that we need to focus on this set of parentheses first then. So we got 8 times 6, which is 48, minus the 21, should have given us 27. So that was that set of parentheses. And hopefully we had something that looked like this afterwards. So now we're focusing on the square brackets. here, and we'll do the multiplication first. So 81, yeah. I've got the 3 plus that 81, which would be 84. Now again, we look at the 4 times the 84, so we should get 336 on that. Right, 84 times 4, 16, carry the 1, 32, 33. Bam. Again, parentheses, yes, we do have parentheses on this. We got 3 plus 4, which is 7. So we got 3 times the 7 squared. Now be careful again, all right? Because instinctively we would want to do 3 times the 7 right there, which would be 21. But that's not what we want to do first. We got to do the exponent first. So we're going to do 7 times 7, right? 7 times 7, which is 49. And then we can multiply that by 3. So 49 times the 3, 27, 12, 13, 14. So the answer here, 147. Another common mistake on this, though, I'm just going to tell this to you guys so that you don't make the same mistake, is that some people just do the 4 squared right there, but it's inside the parentheses, okay? So make sure you do inside the parentheses first. So we got subtraction, but we've got these two numbers that are squared. So let's square them first. 5 times 5 is 25. 2 times 2 is 4, and we got subtraction. 25 minus 4 is 21. Here's a good one. Not because we like it so much as because it's so stinking long. Which hopefully isn't too big of a problem. Let's give ourselves some space there. So let's start with the parentheses first. And we'll start with the parentheses on the left. This set of parentheses. So I got to do the order of operations. Inside the parentheses, there are no other parentheses. And there's no exponents. But there's multiplication here. So I got 2 times 5, which is 10. Minus this 6, which would be 4. Now I still got that 4 in front, and then I'm going to add this 6, but I've got to do this other set of parentheses as well. Once again, no parentheses, no exponents, but I do have multiplication. 8 times 3 is 24. Minus the 17. 24 minus 17 is 7. So now I've got two parts. 4 times 4 and then 6 times 7, which I need to do first. The multiplication, 4 times 4 is 16. 6 times 7 is 42. So I'm going to add these two. 16 plus 42 would be 58. Let me make sure I got the whole thing in there, though. Yeah, we're good. All right, so on this one, let's look for any parentheses first. Now, I do have these two sets of parentheses, the 3 and the 7, but there's nothing to do inside them because they've already been evaluated. So the only set of parentheses I need to focus on is this one because there's stuff I can do on the inside there. So on this one, I've got addition and division, so there are no other parentheses, no exponents, but I do have the division right there. 24 divided by 6, which would be 4. So I've got to do the 8 plus the 4. Yeah, which is 12.
So you go 12 plus 95.
So yeah, then we got that 12 plus the 95. We got the 9 plus the 3 times the 7. And then we'll subtract that 12 plus 95. So the next up, we're looking for exponents. There are none. But there is multiplication right here between the 3 and the 7. So that'll be our next step, is to multiply those, 21. All right, so I do have the rest of this. So now from left to right, I'm going to do addition and subtraction because there is no other multiplication or division. So I got 9 plus 21, which is 30. So now I'll do the subtraction. 30 minus 12, 18. Plus the 95. And when I combine these, I get a 3, 9, 113. That's what I got. Question. So I did take the 12 out of the parentheses only so that it would read better. If I put the parentheses there, it's still the same. It should still be the same. Let's show it there. Okay. So let's start with the 30 minus the 12, right? So I got to borrow 1 to make that a 2. 10 minus 2 is 8. 2 minus 1 is 1. So that's
yeah,
okay.
I did that part wrong. That's where I was.
Oh, that's okay.
So even though the 12.
So just to show that though, we would have added the 95 right there. So that's a 3, carry the 1, 10, 11. Yeah. So that should check out. So the square root business is something we apparently should know a little bit about, okay? Now it has to do with the squares. So if you know anything about the squares, then you should be pretty well off on this, but it's kind of hard to conceptualize for this stuff. So the square root of 49 is like asking what the side length is of a square with an area of 49. See how that gets really mixed up right there?
Yeah,
right?
you already confused me.
Yeah, so here's the thing is it's related to the area of a square, right? So how do you find the area of a square? Well, the side lengths are the same. It's just a very special rectangle. So we do the side length, but we square it. Now we don't write s times s on this because then it spells a bad word and it makes people feel bad, okay? So we'll just, we write it as s squared. Now the problem is if we wanted the area, we would square root both of these. That's the square root symbol. And again, this is why I don't like it, because it's very close to long division, and it looks like long division right there, right? But it's not long division. It's a little bit different because it looks like a check mark instead. That'll come with some experience, okay? Now what that means is the square root and the squared just give us the side length, which would be the square root of the area. So for example, if I had a square with a side length of 6, what would the area be?
6 times 4, right? Because you gotta go with square root, so it'd be...
Well, so the side length is 6, so the area would be 6 times 6, which would be, maybe not equals, but an arrow. So the area would be 36, right? Area and the side length.
Oh, yeah.
So let's say that if my side length was 2, what would the area be?
It would be 2 times 6, so it'd be 12.
2 times 2.
So
Oh, 4.
Yeah, very good. What if the side length were 10?
It'd be...
100. Because it'd be 10 times 10.
Oh, okay.
So what it's saying then is, what if my area were 25? Could you find the side length?
You go 25 times 25, right?
Now that's for the area.
Oh.
This one, it gave us the area. I'm sorry?
5.
5, very good. So the side length is 5 on that. So
Because you gotta divide it by 4.
you got to divide it by itself. Something,
how many times
I'm sorry.
can go into itself?
Yeah, something
Right.
goes into itself will give us the area.
Okay.
Yeah. Now I'm doing this without any pictures and stuff, which probably makes it even more difficult. Which is why I hate that it comes up right now.
So the square root of 49 would be 7.
There you go, nailed it.
The exponents?
The square roots comes in, depends on how you write it. And when it's written like this, it's treated as a parentheses.
Okay.
Yeah,
So
very
we
good.
have to do that first.
Yeah. Now we do have 2 sets of parentheses essentially on this, right? We got the 3 minus 2, which is 1. But then we got the square root of 49, which is 7. Okay, so again, if we had an area of a square with 49, its side length would be 7. 7 times 7 is 49. So now I have this new, it's a little bit more simplified expression, and we've got rid of all the parentheses. What I have now is this 4 squared. 4 times 4 is 16. So I've taken care of the exponents now. So on this one, yeah, we got order of operations still. We've taken care of parentheses and exponents, so we've got to look at multiplication or division from left to right. So I've got multiplication here between the 1 and 16. 1 times 16 is 16. Then I've got 42 divided by 7, which is 6. So now we have this even more simplified problem. So now from left to right, because we just took care of the multiplication and division, we'll do addition and subtraction. So 59 plus 16, 5, 6, 75. Yeah. And then I've got the minus 6 still, which when I combine these, looks like I get 69.
So I,
Ashley runs 2 miles on Monday and 3 times that on Tuesday. If she wants to run a total of 20 miles this week, how many more miles does she need to run? So let's set this up. We've got a couple values that we need to look at. Monday, and then we're going to add her total to Tuesday, and she wants the total to be 20 miles. So we'll figure out how much she'll need to run, I guess, for the rest of this week. So Monday, she ran 2 miles. Tuesday was 3 times that. So we can write it as 3 times 2. But that would just give us 6, right? So a total for this week, Monday and Tuesday, 2 plus 6. So far she's run 8 miles.
so she needs to 12 more miles.
Very good. Her goal is 20 miles. But she's already run 8 of those miles. So we'll subtract that out to see how much more she needs to run. 12 miles.
You gotta write out.
All right, 25. John earned $12 on Saturday, but he only managed to earn $6 on Sunday. He earned twice as much the previous weekend. How much money has he made over the 2 weekends? So this weekend, specifically,
He made 18.
yeah, right? So you've got Saturday and then Sunday,
And you have times that by 2.
which was 12 and 6, which we'll add. So this weekend, he's got $18. Last weekend, though, was twice as much, right? So we got the $18 that he made this weekend, but twice that, which is, yeah, 36 bucks. So when we combine these, 36 plus 18, what do we get? $54?
Oh, yeah. I forgot you had